All right. Let's see. 4.5 part 2. We're going to shift our sine and cosine graphs. So what we're talking about today, our functions, we're just going to add, so we already know about our changing our amplitude and changing our period. So we have y equals a sine, and I'm going to write bx minus c plus d. And we can also, we're also talking about our cosine, bx minus c plus d. All right, so we already know that A changes our amplitude, our vertical stretch. B changes our period, so that gives us a horizontal stretch or compression. And I'm going to hold off on this one for just a second. What does D do if we add something outside like that? Vertical shift, right? D gives a vertical shift. And after our vertical shift, our graph goes A, absolute value of A, our amplitude, units above and below our new axis. That's why yesterday I said the amplitude tells us how far above or below the axis we go. So if we don't have a vertical shift, it's the x-axis. But if we have a vertical shift, we get a new axis, which is the line y equals d. So we shift from the x-axis up to y equals d or down to y equals d, and that's going to be our new axis. And the amplitude tells us how far above or below that new axis we go. And what does this c inside here do to our function? C gives us a horizontal shift. Now, we have to be careful when we have our function written like this because sines and cosines are periodic, the change in the period and the shift kind of get mixed together, and so we want to make sure we can see each of those separately. So what we're going to do before we decide what our horizontal shift is, we're going to rewrite our functions. And I want to factor out this b. So I'm going to write it as y equals a sine b times x minus, and we factor a b out of the c. What are we doing when we factor? What essentially are we doing? Dividing. So we're going to write this as x minus c over b plus d. And we do the same for cosine. And then our shift is c over b. And we call this the phase shift. So if our b is multiplied, I'll scroll back down just a second, multiplied like this, we want to factor that out of that expression first in order to see our horizontal shift. So that way the stretch and the shift we can see them as separate things. They're not mixed together. All right, so what I want to do is go through several examples of working with these functions where we have some shifts, horizontal and vertical shifts, to talk about how we go about sketching our graphs, and we might see a couple of interesting things happen here. All right, so questions about our shifts. So let's start with an easy one. So all of these, we're sketching a graph. So I'm not going to write that for each one. We're sketching a graph. Y equals, for this one, cosine x minus pi over 2. So what I usually do, or the way I think about these, is this one we don't really need to worry about the amplitude and that kind of thing, but I'll just write it out just to make everything explicit. Amplitude is 1, b is 1, so our period is 2 pi. We get our key points every quarter period, so every pi over 2 units. And this x minus pi over 2, what does that do to our graph? Shifts it right pi over 2. So instead of starting our graph at 0, 0 or at 0, 1 like we would normally do for our cosine function, we're going to start it at x equals pi over 2. And it's nice that our key points and our shifts are in the same units. So now we can start labeling our axes. I'm going to label in terms of pi over 2. And I'll go this way as well. All right, and our amplitude is 1, so I'll label my y-axis as well. And normally our cosine function is going to start here, but we're shifting right, pi over 2. So I'm going to start here. And then we get our key points every quarter period. So this part of the function is going to look like this, our graph. And then we're going to go this way. And do we see anything interesting about that graph? That looks like a sine function. We can think about a cosine function as a sine function with a phase shift of pi over 2 to the right. So the cosine function and sine function really are the same thing. One is just shifted from the other. And if we think about how the x and y coordinates work on the unit circle, we can see that they're pi over 2 apart. Because sine of 0 is 0, but the cosine of pi over 2 is 0. So they're shifted by pi over 2. Kind of an interesting thing. So if you're modeling something with a sine curve or a cosine curve, you can model it with either one. One's just going to be a shift of the other. Sometimes it's more convenient to do one than the other. All right, so questions on that graph. That was a pretty easy one. All right, let's look at one where there's a little more going on now. Still sketching. Y equals 2 sine 2x plus pi over 2. So I think I said last time, and just to repeat, what will happen when as we're graphing trig functions, we get better at working with fractions, which is a nice bonus. I'm going to rewrite this immediately since we have the two x here. I want to factor that out. So I get 2 sine of 2 times x plus, and when I factor a 2 out of here, what do I get? Pi over 4 divided by 2. All right, so I know that the amplitude is 2. B is 2. So the period is 2 pi over 2, which is pi. We get our key points at pi over 4 units. And this shift, what is this shift? Pi over 4 to the left. And we have our nice our key point interval and our shift. Those units are compatible. We'll do one example where we have to do a little more work with that. So now we're ready to sketch our graph. Now that we have all this information, I'm going to label my axes in terms of pi over 4, or my x-axis at least. And I'll go this way. All right, and well, our amplitude is 2, so I'm going to do this. And normally we would start our unshifted sine function here at 0, 0, but I'm shifting left pi over 4, so I'm going to start it here. And then I'm just going to plot my key points every pi over 4 units. And I'll go back this way a little bit. And there's my couple of periods of that graph. What's interesting about this one? It looks like a cosine, but with a period of pi and amplitude 2. So the two graphs, they're very similar. They're just a shift from each other. And if we look, our period, we get one period. If you want to double check your graph, we get one period from pi over 4 to 3 pi over 4. And that should be pi units. So we just to double check that you got your period, and you can see it here. But we started at negative pi over 4 and we went over here to 3 pi over 4. It can be helpful. Some students find it useful to look at where we have a full period. And we can do that by saying we get one period. Now you don't have to do this. This is just some students have like to be able to visualize this. I like just working with the key points. We get one period from 2x plus pi over 2. This quantity here equals 0 to 2x plus pi over 2 equals 2 pi. Just like we talked about when we figured out how the b value changes our period, we know that when the angle, this whole thing, goes from 0 to 2 pi, our sine function, we're going one time around the unit circle, we're going to repeat. Well, if we solve this for x, we would get x equals negative pi over 4 to x equals 3 pi over 4. So we should get one period between negative pi over 4 and 3 pi over 4 if we solve each of these for x. And then you can divide that one period into 4 equal pieces to get your key points. So some people like to sketch the graph that way or double check their sketch that way. So just another little tool that you could use if you want. All right, so questions there. All right, let's look at an example with a vertical shift and with also with a reflection. And then I'm going to do one example, the last example, where the period and the shift have different, the denominators don't play as nicely with each other as our examples so far have done. All right, so here is our function that we want to graph. First thing that I'm going to do immediately when I see it like this, I'm going to factor here 2 minus 1.5 cosine of 0.5 x plus, and when I factor a 1/2 out of here, what does that do? What do I end up with? When I divide by 1/2, so we get 2 pi. All right, now we have all of our information. Our amplitude, 1.5. B is 0.5. So our period is 2 pi divided by 1/2, which is 4 pi. What is this negative 1.5? What is that going to do to our graph? We're going to reflect over what? And we're going to have a new axis. So I'm going to say reflect over the new axis. And we get this, what is this 2 out here doing? We get a vertical shift of 2. And this 2 pi, horizontal shift, two pi to the left. So we've got a lot of stuff going on with this graph. So let's sketch it. So our amplitude, again, it tells us that we're going to go 1.5 units above and below our new axis, which is going to be at y equals 2, because we're shifting up to y equals 2. So I'm going to say there's 1, and I'm going to put, I'll do a green line there. There's 2, and there's 3. And because my shift is 2 pi and my period is 4 pi, oh, I need my key points. Every pi units. Quarter of a period. So it's going to be convenient to label my axes in units of pi. So I'm going to do pi, 2 pi, 3 pi, 4 pi, and I'm going to go negative. All right, so our cosine function usually starts at 1, 0, but I'm shifting up and I'm reflecting. So my cosine, and I'm shifting over 2 pi to the left. So I'm going to start 1.5 units down from my axis. So the vertical reflection has us start below the axis instead of above. And then my key points every pi units. And up here is 3.5. So I go here. And I'll do another one here. Like so. And there's 2 periods of that graph. And that looks like an unshifted, unreflected cosine around that axis. So because trig functions are periodic, we get things that repeat, or things that look the same even though we can write them in different forms. All right, so questions there. That graph has a lot going on. Okay, let's do one example where these units of our key points and our shift, our period, we have to do a little more work with those. And I need to change one thing really quickly here. Okay. So this one we want to sketch a graph of y equals sine 2x minus 2 pi over 3. And immediately I'm going to rewrite that as sine of 2 times x minus, when I divide by 2, I get 2 pi over 6, which is pi over 3. Sophia, I was just thinking in my last class, so in my calculus class, I don't collect the homework. I go walk around the class. And I'd forgotten about it today. And so kind of like you asked about the quiz, the student said, Mr. Beamer, don't you need to check the homework today? So I was just thinking about that. Made me laugh. He was very popular in that class right then. All right. We have our information. Our amplitude is 1. B is 2. So our period is 2 pi over 2, which is pi. We get our key points at pi over 4 units, but our shift is pi over 3 to the right. So for this one, yes.
Did you get the key points of pi over 4?
1/4 of the period. So always for sines and cosines, you get your always get your key points at quarter period spacing. So this one, I can't just label my x-axis in terms of pi over 4 because my shift is pi over 3. So what I have to do is start my graph at pi over 3 and label my axis pi over 4 units from where I start. So we have to work with these denominators. So I'm going to start my graph here at pi over 3. And in order to get my key points, I'm going to rewrite pi over 3, or sorry, pi over 4 as 3 pi over 12. So I need a common denominator. And pi over 3 is 4 pi over 12. So now I need my key points every quarter period from quarter period intervals starting at pi over 3. So I get 4 pi over 12 plus 3 pi over 12, which is 7 pi over 12. Then I'm going to add another 3 pi over 12, which is 10 pi over 12, or 5 pi over 6. Then I'm going to add another 3 pi over 12, which is 13 pi over 12. It's 10 pi over 12 plus 3 pi over 12. And then I'm going to add another 3 pi over 12, so I get 16 pi over 12, which is 4 pi over 3. And my amplitude is 1. I'm going to go here, -1. I'm going to start my graph on the x-axis because sine of 0 is 0. I'm going to shift that over. And then I'm going to plot my points here. Go down a little further. There we go. And there. And if we wanted another period, we could continue adding units of 3 pi over 12 here. Or we can go in the negative direction. If I want to go this way, I need to subtract 3 pi over 12 here. So this is 4 pi over 12 minus 3 pi over 12. So my next key point is at 1 pi over 12. So my graph goes down here. It doesn't have a minimum at the y-axis. And then I have pi over 12 minus 3 pi over 12. So 2 pi over 12, which is negative pi over 6. And I could continue on that way. So we need to go in intervals of pi over 4 from where we start. And because our fractions don't have the same denominators, we have a little more work to do. So just be careful of that. So our graphs don't always have a maximum or a minimum or an intercept at the y-axis. Okay, questions there? All right.
Yeah, I have a question.
Oh, 21. This one should be 22. 22. Where am I? 77. There we go. I could have. I think what I meant was this. That's what I meant to write.